Welcome to Sri Digambar Institute of Technology, Dosa. My name is Mr. Hardish Kumar. Today we will discuss about the Faraday's law. Faraday law, it basically flux linkage with a coil changes. The voltage is induced in it. The magnitude of this induced voltage is equal to the rate of changes of the flux linkage. Right? Continue. We can quantify the induced EMF, describe qualitatively in the previous sections of this lecture by using magnetic flux. Experimentally, if the flux through n loop of wire changes by d phi b in a time dt, the induced EMF is permittivity equal to minus and d phi b upon dt. The Faraday law of magnetic inductance. This is the and d phi s upon dt. Faraday law of inductance is one of the fundamental law of electricity and magnetism. I wonderful why this sign negatives. So in which case, according to this inductance is very critical conditions, electricity and magnetisms we use of the according to Faraday. Whenever the flux linkage with the coil, right, this is the coil L, the coil changes, the voltage is induced, in which case, right, current flow of I, the magnitude of this induced voltage is proportional to the rate of changes of the flux linkage. So V equal to proportional to d over dt and phi, right? That means V equal to V proportional to and phi. So this is the d over dt rate of changes. So in which case तो V equal to कितना हो जाएगा माइनस का n साइन d phi over dt. In terms of current we can write, so current कितना हो जाएगा V equal to माइनस के and d phi over dt into करंट कितना होगा di over di, right? So this current we calculate of again equations V equal to minus के and d phi over di into di over dt, right? But inductance d phi over dt, d phi over di equal to कितना होता है L, होता है सेल्फ इंडक्टेंस. So the voltage in which case self inductance V equal to minus के NL di over dt. This is the volt. So this is the self inductance of the Faraday law. So Faraday law we calculate of the voltage V equal to minus के NL di over dt. Here N number of turns of the coil, L self inductance, V voltage of the self inductance, and di over dt is the rate of changes of the current. So whenever this flux linkage with the coil changes, right? So this is the Faraday law. In equations, Faraday law of the magnetic inductance. So this is the another expression of Faraday law. Close integral E dot ds equal to minus and d phi v upon dt. This is the we will use the version in the next lectures. This is the most example of Faraday law. Here, in which case magnetic toward a coil of wires. So this is the north pole and this is the south pole in voltage V. So this is the coil in numbers of turns coils. So N equal to 5 turns and ampere equal to 0.002 m square. So dV over dt equal to 0.4 T over S. ठीक है, तो probability of equal to minus k and d phi v upon dt equal to minus k and t integral b dot dA upon dt. Probability of equal to minus k and dVA upon dt. What assumptions did I make here? So probability of equal to minus k and a dV over dt. So we will pull to this formula this value n and a की. So we calculate of this value will be 0.004 voltage, right? Way to induce any EMFs changes with the B shape of the in this way, changing the area of loop in the field. This is the this and this. So phi v equal to d phi v equal to b dot dA integral of b dt upon dt. So changes the area of the loop in the field, this, right? Here in which case we have the changes of the flux. So the proportional to the rate of changes of the linkages of the in surface independent of area. Way to induce an EF, continue. Changes the orientations of the loop in the fields. In between of the angle, theta equal to 90 angle and theta equal to 45 angle and theta equal to 0 angles. So in which case the maximum flux and inward and flux will be the maximum flux, and this is the increasing case and this is the decreasing case of the Faraday law. Thank you for watching this video.